the second lecture on the arithmetic operators. So the agenda of this lecture, we're going to discuss about the binary arithmetic operators. Okay, so there will be you'll know some of the concept if you know the maths little bit. So your concept from the maths will recur here. Okay, so let us see what are the operators we have. We have that plus, so means to perform the addition between two number we can use this. Okay, so we need two operand, operand 1, operand 2, so that's why it is called binary addition. So the value, this expression will be solved first and the value will be assigned to a. Similarly, if I use this subtraction and if I write a equal to 5 minus 6, so this particular expression will be solved and will be assigned to a. So outcome of this one will be minus 1. And for the multiplication, we don't have the multiplication symbol in our keypad, so we'll use asterisk. So asterisk is reserved in all the programming languages for performing multiplication. Okay, so if we do 5 multiplied by 6, so it will be solved and that value will be assigned to a, whatever we have on the left hand side. And then we have the division. So for division we are using front slash for the division. Okay, front slash. So there are some different rule we need to take care. So just if I take both the number as integer, suppose if I take 30 by 2, so it is a perfect division, so it answer will be 15. But what if I just do 7 by 5? Okay, so we'll need to discuss this thing, very important, because here some fractional outcome will be there. 7 by 5 means it is 1.40, right? So some fractional values also there. So what will happen to this division, because 7 and 5 both are integers. Okay, we need to check it. In addition to this, the last binary arithmetic operators, we have the remainder. Okay, remember this operator is only useful with integer data type, int data type. Careful, we cannot apply this operator with floating point, any version of the floating point number, neither with float, neither with double, neither with long double. We have to do with the integer data type. So it actually returns us the remainder. Means if I write suppose a equal to 15 modulus, what is the name of this? Modulus. Do not call it as percentage. Okay, percentage we called it when we use it with the scanf and printf. Okay, so based on the context its meaning is changed, because we have the very limited symbol in our keypad, right? So based on the context its meaning is changed. So for an example, suppose if I write 15 modulus 4, the outcome will be 3, because 3 is the remainder right now. So 15 by 4 if I do, so you can see the remainder is 3, so it will give me the remainder. Okay, and most important point, you cannot use this data type other than integer. So for the floating point remainder, we will see there are separate concepts, or the separate methodologies exist. Okay, so this is the very basic part, but not over. Our topic is not over yet. Let's go back to the online GDB compiler and see the few important parts. Okay, so let us take two integer variable. Okay, a equal to 5 and integer b equal to 6. And now suppose if I use printf, instead of storing the value, if I use directly within the expression. Okay, so here we can pass a plus b. It is not necessary that each and every time we pass some variable or constant. We can pass the expression also, so that expression will be evaluated and the value will be displayed in place of percentage d in your output screen. Okay, so here what we are doing a plus b. So careful, what is a plus b? So you can also print them properly, right? So we can replace this by percentage d, and it is also I can replace by percentage d, and now we can provide this value in the argument, right? Okay, so let me just add a \n here and just execute this. You can see we get the correct output, 5 plus 6 equal to 11. You can also check up with the negative values. So now what I am doing, 5 minus 6, although I am doing addition. So in mathematics, when a plus is multiplied with negative, the outcome will be negative. Plus and negative, answer will be negative. So what this expression will happen here, let me just write here so that you can understand. Okay, so here what is happening, the value of a is 5, no issue, but you are using plus, okay, but b is minus 6, right? So what will happen, 5 minus 6, so answer will be minus 1. Okay, we get the value. I hope you understand, it is clear now. Okay, with the addition. Now if I just replace it, so let us just print its other operation. So now if I want to do subtraction between these two, I need to replace it, right? Now I want to do multiplication. So remember this sign I am using here doesn't make any impact. It is only a string because I put all the thing inside the double quote. So it is a string what I going to display in the screen. Okay, actual operation done by the third argument of the printf, this expression. Okay, now if I do division, I told there are some things that we need to discuss. So we'll discuss now. Let us just, and now we left with the remainder. Okay, now execute this and see. Okay, so another issue here, you can see the warning. Let me just show you the warning so that you can understand. All the lines are okay in my code. Only line number 15 is saying that I cannot print. It is not the correct way to print the percentage symbol. Okay, so how we can print a percentage symbol here? Can I use another percentage and let us just check? Yes, we get it correctly. Yeah, we get it correctly now. So yeah, fine, it is fine now. Now let us check how it is works. 5 plus 6 is 11, fine. 5 minus 6 is minus 1. 5 multiplied by 6 is 30. So basic mathematical operations. 5 divided by 6, which is not 0, but we get 0. So we'll come to this point. Just hold a minute. 5 modulus 6, as I told, it will give us the remainder. Yeah, we get the remainder properly, no issue. So what about the floating remainder? So floating remainder, we can use one function. Include, we need to use from math.h. If I am not wrong, there is a method called fmod printf, right? So we're going to see percentage f, percentage f, okay, and also equal to percentage f, and now I'm passing the value 3.4f and 2.3f, both the operand, and finally I need to apply here fmod. Okay, let me just pass it 3.4, then it double, so I'm passing both the operands here, and it will be print me in a double. Okay, so format specifier is lf. Let us just execute and see. Yes, yeah, this is the method, as I told, you can use for the floating point remainder. Fmod is the method name, and for that you need to include the header file math.h. because it is a library function, part of the math library, and that particular function is already defined in the math library. Okay, so if I just divide 3.4 by 2.3, I'll get the remainder of 1.1. Careful, in all the functions available in the math.h, they accept only argument of type double. So that's why you can see I did not prefix f here, because if I prefix f here, that particular constant 2.3 will become float and 3.4 also become float. Let me just show you. Okay, there is no error, it works with both of them, but normally I, as per my knowledge, methods in the math.h will accept the parameter type double. So might be they are typecasting to the double, because float and double, they are type compatible. Okay, no issue. Now all the things are clear, but one thing is we have not discussed yet. Line number 13, the division operation, why we get 5 divided by 6 equal to 0 instead of 0 point something, right? 0.4333 will be the answer, right? So now it's time to discuss. Okay, so let's come back. When we use the division operation, okay, whenever we write 5 divided by 6, 5 divided by 6, what C compiler, how C compiler works? So C compiler says that look at the type of both the operand in the division operation that you have used. Here 5 is also integer, right? And 6 is also integer, correct? So in the C compiler it is defined that if we divide an integer by another integer, answer will be always in integer. So fractional part will be truncated. Okay, so let us re-verify this. Now suppose instead of 5 divided by 6, if I use some large number, suppose 15 by, here also 15, yeah, 15 by 6. So now 15 is larger than 6. So we are hoping some values over here. So see, we are getting the 2, but we are not getting the fractional part. Okay, you might thought that you have used percentage d here. That's why maybe the reason. Okay, so let's replace this percentage d by percentage f and then try. Okay, now see, even we did not get 2, I only get 0, 0, 0. Because this expression, integer divided by integer, answer will be an integer. Whatever format specifier you use, it is not a matter of concern. If I use percentage d, I'll get the portion correct output, fractional part will be truncated, because compiler says that you told me to print in d means decimal means integer. I cannot print the fraction even though this expression doesn't give me the fractional part. So as per the C compiler, whenever we divide an integer by integer, even though some fractional part is there in the result, that fractional part will be truncated. But how to take care of this? If this is the process, we'll always get the wrong output. Our mathematical expression goes wrong. Wait. C says another way. Suppose if you are not sure about this two operand, are they going to produce the whole integer number or with some fraction? What you can do? Typecast the whole expression into float. Says that typecast. So typecast it, what it will be done internally, this particular operand will be converted to float. So now instead of integer by integer, it is going to do float by integer and answer will be in float. So that means we are also going to get the fractional part. It will be not truncated. Then there might be another question in your mind. Then what we can do in the printf? Printf we are using percentage d in this particular example. Here. Okay, here we have used percentage %d. So two changes we need to do. Whenever we do the division, it may be a whole integer number or with fraction, because right now we are giving the values directly. If we take the input from the user, you don't know what value user can enter. So in such case, never print the result of a division with percentage %d, always print the result with percentage %f, and any of the operand you can convert to float, or if you go with the integer, no problem, but result may be in fraction. So what you can do, just typecast the operand in float, so answer will be in float. So here two changes we need to do. So let me just do the changes in front of you. Let me just comment this line and modify so that you can find what changes I have done here. First change is division result always print with percentage %f and convert to the float, the operand. You can convert to this one in a float. Okay. So now execute and see. Now see, we get the correct output. That is the most important part. You should take care. Okay. So now another thing, let me just put this one in comment and copy and paste, modify this f. Now suppose that if sometimes we are using literals directly. So if I write 15/6, I did not use any variable. Okay. So is there any other way that we can get the same result? Yes. Convert this number to float. Anyone. Suppose if I just do this, and now if I just execute, correct result, anyone. Okay, let me just put this thing in comment and copy this line and execute it again. Okay, so now instead of this, I'm modifying this. Sorry, yeah, it should be 6.0. Now execute, we get the correct output. So two approach you have. You can convert any of the operand into float, or you can typecast it. Okay, so can I get the same result if I typecast the complete expression instead of the particular operand? Okay, let us see and try. Always just type the code and see the output and observe, else you'll not understand the coding. Okay, so here I am not using, and I just want to typecast it to float the complete expression. So this is typecasting operator actually. Okay, typecasting operator. So now see, I've used percentage %f. Okay, see, truncated. Fractional part is truncated. I get the decimal place up to 6 decimal place because of integers. Because of float, suppose up to 6 decimal place, but I did not get the correct result. So solution is not to typecast the whole expression. Solution is typecast to any one operand in a float. Then you will get the correct result. So if you do one division operation, you can go with at least one as a float, so get the correct result. So these are the very basic thing you should remember. Another, never try to divide a number by 0, you'll get a runtime error. So let me show you. Never do this. So if I try to divide it by 0.0, okay, run this. So see, I get an infinite number. In the GDB online compiler, take care, I get the infinite number, but in other offline compiler might be you're getting runtime error. Your screen might be hold for a couple of seconds, so do not confused. Okay, this is the reason. Never divide a number by 0 in programming. Before you divide that number by 0, you can check the number. So we'll see shortly, once we cover the operator, we'll see conditional statement, how to check this. Okay, so these are the very basic part I have covered regarding the binary arithmetic operators. Now next part is what if instead of division, if I put this floating, if I mix integer and float together, how they reacts. So let me just discuss now. Okay, here only we can just have it, just discuss it here, and we'll go for the demonstration. Next 5 minutes we can wind up this particular topic. Okay, now suppose I am not going to write any type here. If I write a equal to 6 plus 3.5, in mathematics what is the result? In mathematics result is 9.5. Assuming that whenever I use any fractional number, it is a float. Okay, okay, right. So what is happening in mathematics? That result is coming in the form of a particular type which can easily adjust the integer part as well as the fractional part. Result is not in integer, always in upper type. So means whenever we do 3 plus 3.5, okay, so the expression will be promoted. The second operand, which is in other type, it will be first promoted by the compiler internally, okay, and then it will perform the addition operation. Okay, so it means whenever we do the mathematical operation, arithmetic mathematical operation, and with a mixed data type between integer and float, the result will be always in float. So careful while declaring the L value type. Do not use L value type as integer. Any operation, it can be positive addition, it can be subtraction, division we have already seen, it can be multiplication as well. In any arithmetic operation, if in a mathematical expression any of the operand is float, the outcome will be always in float. Okay, so let me show you quickly. Printf, so I've used percentage f, right, and now I'm using 3 plus 5.6 f. Get the correct result. Okay, so let us try to print with the same one with the integer. Let's see what we are getting. Backslash n d. Okay, so see what we are getting. It is saying that format percentage d expects argument of type integer, but argument 2 has type double. So it is saying that this particular type given me in the form of double, why you are using percentage d here? Okay, I hope you clear now. So expression is here integer, this one is expecting integer, but you provided the double, means double is a floating point type. So it is suggested that instead of percentage d, use percentage f. So we get the correct result. Any operation. Okay. Type promotion I called it. So careful. If instead of percentage f, if you want to save the result, what you need to do, check carefully what are the types of right hand side operand. Now here you might be confused little bit. Sir, there are 3 integers and 1 floating point only. Why I should use float here? No. If I use integer, I may lose the information. But if I use float in this side, I will not lose the information. That is the key part. Okay. So I hope you like that particular discussion. We have divided the arithmetic operator discussion on 2 parts. Previous video we have explained about the unary, and most important part of the unary is the increment and decrement, pre and post version with another operand as with the assignment operator, without assignment operator. So practice it, and here everything is same in the mathematical formula, like maths. Only one thing is that when you do the division, we need to take care 2 things. Never divide a number by 0, and when you divide a number integer by integer, answer will be always integer. So if there is a fraction in part of the result, it will be lost that fractional part. So 2 solution is there. One solution, convert any of them as in a float. Okay, either you can use directly constant 3.0, or if you are using some variable, typecast it to the float. We'll get the correct answer. Third point we have discussed here, that do not use this modulus operation, modulus operator with the floating point type. Okay, it is only useful with integer data type. If you want to perform the modulus operation between the float to get the remainder, use the function fmod and pass the operand. So a by b will get the remainder in a double. So to use this function, we need to include one header file math.h. Okay, this is it. In the third part of the arithmetic operators, we're going to discuss about the operator precedence and associativity. Okay, and thereafter we can easily move to the conditional statement with relational operators and conditional statements. Okay, so give me a thumbs up, and if you like my content, please do subscribe and share. Thank you.